and get started. So welcome to our 4-H in the Field workshop. A couple of you guys have been to some of our other ones. We've done dog training. On Tuesday, we had sewing and construction and like cloth fitting. We have Jonathan here who's going to talk about LED software design. Next week, we've got photography and let's see, what does Haley do? Shoot, I can't remember now what Haley does. Anyway, and then we also have
what's her last name?
Oh, I can't remember. She's another software person. She used to work, I think, with you.
She works at SDL. I don't remember exactly what she does, but she's
Okay,
a software developer at SDL.
Yes, another software one. And then we have our final one on the 28th of May. We've got 2 aerospace engineers that are coming on to share what they do with us. So that's really exciting. But I'm going to just let Jonathan introduce himself and tell us a little bit about what he does, and then we'll just go from there. So take it away, Jonathan.
Okay, so I want to kind of ask some questions real quick. So you can raise your hands on camera or give me a thumbs up, whatever works. Who knows what an LED is? Yeah, you know what an LED is? All right. Who's ever been on the freeway and seen those great big signs? But they're not the normal signs. They're the ones that's actually like a screen, so they can play videos or change pictures and things like that. Or been to maybe a sports stadium, been to a football game, something, and seen the screens that they have there. So I work for a company called PrismView, and we make those screens. And those screens are made out of LEDs. Has anybody ever looked at your computer screen? You look at your computer screen and you lean in really, 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 really close, and you can maybe sometimes see that there's little red, green, and blue dots. So the displays that we make use LEDs, red, green, and blue LEDs, to make all the different colors. So you've probably heard of the primary colors. You can make any color that you want with just those 3 colors. So to start with, I want to show, so this is an LED panel. This is usually what we work on. So those signs that you've seen on the freeway or in the football stadium, they're made out of panels like this. And if you look real close, you can see there's a bunch of little white dots on there, and every one of those white dots is 3 LEDs. There's a red one, there's a green one, and there's a blue one. So by controlling how much each of those colors is turned on, we can make whatever we want. So let me just plug this in real quick. It's working just a second. There we go. So I can change the colors on that guy. I can animate it to different patterns and displays and things like that. So so basically the software that I write software that takes in the video, breaks it apart, and decides which LEDs to turn on. And there is a little computer on the back of every one of these modules. I have today probably the smallest computer any of you have ever seen before. Oh, and I'm dropping. There we go. So that's the computer that's on the back of every one of those modules. And the code that I write runs on those modules, runs on these little computers, and it figures out which LEDs to turn on, turns on the right ones at the right time, turns them off, controls the brightness. But then eventually what we do is we put together a whole bunch of them, and we end up with a great big sign like this. So this is the sign I have in my office that I used to test. Only half of it's on right now. The other half over there is I'm testing some stuff. But this half you can see, again, is just made up of those same little cards, little LEDs, little pixels, and I can make all kinds of big pictures and images and things show up on there. Sorry, I'm moving my computer a lot. I know that's not great, but let me just switch this over. See if this looks familiar to anybody. So again, it's only going to be half of it on right now, but it should come up. Does that look familiar to anybody? You know what that is? Can you see what that is? I know only half of it's on. It's kind of bad, but that's, I mean, you can see it's a Mario game. So we can put any kind of image that you want up on there. Yeah. So what questions do people have? And I have more to talk about, but I want to know what you guys think or what you want to know or what. Want to make
is it
Go ahead.
is it just like coding?
Yeah. So have any of you ever written code before? What kinds of code have you written?
Like in 4-H, I used to go to cat. Well, my dad found this website. I forgot what it's called, where it was like you would make these games and you had to move them and use certain codes to help like move.
Scratch?
Like, yeah, we use Scratch a lot, but we also use like one. Do you know? I don't know what it's called, but.
Yeah, so the code that I write is all in C++. Has anybody heard of that before?
Yeah. I've been able to work with it a little bit.
You played with
with Raspberry Pi.
You did it on the Raspberry. I didn't get all of that, but I heard that you've done a little bit on the Raspberry Pi.
Yeah.
So I mean, the Raspberry Pi is similar. If you look at the Raspberry Pi, it's got a little chip on there too that is the actual processor. But yeah, so on every single one of these, like I said, there's a little computer, and that little computer is running about 3,000 or 4,000 lines of code. It's all written in C++. And then there's another board like this board here that actually sends the video, and that again has a couple thousand lines of code. And eventually you can just plug into the sign with like an HDMI cable, and the code that we write breaks down that HDMI signal into controlling the LEDs. Does that answer your question? Is that
Awesome. Okay, so here we have a couple questions coming in. So we have one from somebody appearing as Mateo. How big can an image be presented? I'm assuming that means like how big of a screen have you typically worked on, or
yeah. So our system supports full HD. So if you know what that is, if you've seen that before, obviously to do full HD, you need a lot of those cards put together. I don't have enough room in my office to put that many cards together. So the sign I have here is not full HD, but the big billboards and the big stadium displays and stuff that you see, they can be over 1,000 pixels wide. There also are different pitches. That's the distance between the LEDs. So you can have higher or lower resolutions. The biggest display that we have worked on right now, we're actually doing the display for the new Rams stadium that they're building in California. And it is basically one big long ring that goes all the way around the football field. The whole thing is a display that's a couple stories tall. And we treat it as several of those displays put together, but it's essentially one giant display with millions of LEDs. I got one here that looks like it got sent to me privately. So what education does it take to do what you do? So I have a bachelor's degree in computer engineering with minors in computer science and math. So I went to school for 5 or 6 years, just here at USU here in Logan. And that taught me a lot of what I needed, but really a lot of what I do at work, I learned at work. At school was an important foundation to learn the basics and stuff, but I mean, they didn't teach me about LED displays at school. They just taught me about C++, and then I came here and learned how to use C++ on LED displays.
So with the LEDs, are they like kind of like in football fields? Are they able to sustain like all weather types?
Yep. Yeah. So let me grab. So the LEDs. Who's ever seen a circuit board before? So if I can put this up real close here, you can see those LEDs. Each of those little white squares is an LED, and it's soldered onto this circuit board. So by itself, that's obviously not waterproof, right? If I pour water on that, it's going to cause problems. Once they're done, once they're soldered onto the board like this, we have a special, basically rubber that we dip them in that waterproofs them, and then there's a plastic case that each one of these goes into, and that holds it all together. That protects it from the sun. There's actually a little, like a visor almost over each of the LEDs that protects it from the sun, and that also has all of the mounting screws and things to put the whole thing into the frame once it's done. So yeah, once it's done, it should be completely waterproof to be just fine in the rain.
Okay, we had another question. How many lines of code does it take to display a picture on the Rams stadium? This is from the iCode.
So it's kind of cool actually, because like I said, there's a couple thousand lines of code that run on every one of these cards, but it's actually the same code on every card. So once I have one card working, like this one here on my desk, once I have one card working like this, I can just chain a whole bunch of cards together, and each card has the same code, but they're smart enough to figure out where they are in the sign to show the right part of the image. So it's a really, really big sign, but it's actually the same code just repeated over and over and over and over and over again. Does that answer your question?
Does anybody else have anything, or should we let him? Oh, here we go. Justice wants to know, how long do the panels last until you have to replace them?
So it's kind of interesting because we're constantly making better versions of the panels. So the panels that I'm working on are our newest generation of panels, and they're not actually out anywhere. The signs that you see don't have any of my code on them yet. I'm working on the new generation that's going to be coming out this year. But we have signs still out that are still working, that we're still servicing, that are anywhere from 5 to 10 years old. So they do last for quite a while. But the cool part is that even if something does happen to the sign, we don't necessarily have to replace the entire sign. We can just go pop out one card and put a new card in. So we have a great big warehouse full of the older generations of cards, so we can really quick and easy replace just one card at a time. And that way we don't have to worry about soldering anything in the field or dealing with the rubber or anything. Just unscrew one card, pull it out, put a new one in it.
That's awesome. Okay, do you guys have anything? If not, okay, so tell us, Jonathan, a lot of these kids have done stuff at Cash Makers.
Yep.
What have you volunteer with Cash Makers and 4-H a lot.
Mm-hmm.
What have you done with them, and how do you think that they can use the skills they learn at our camps and clubs to become what you do?
Yeah, so I know a couple of you mentioned that you've done stuff with Raspberry Pi or with programming online. The programming that you learn with that is very much, it's related to the programming that I do, or it's a good stepping stone towards the programming. One more time, who's programmed before? Who's done programming in the past? Who's done anything programming with, I mean, when you start to program, usually a lot of times one of the first things you do is you just get it to print out a word on the screen. But a lot of times if you're programming with like an Arduino or a Raspberry Pi, you'll blink an LED. Has anybody done that before?
Yep.
I mean, so it's similar. It's very similar. You're basically just doing the same thing 900 times all at once. So camps that I've taught in the past at Cash Makers are Arduino and Raspberry Pi, like I mentioned. We've also done Scratch. We've done C++, just like making game engines and things like that. All of that is actually helpful. All of that is a good start. It gets you kind of thinking about how code works and how a program works. Computers are interesting. If kind of probably most of us would say that computers are really smart, and that's sometimes true. Computers are really stupid most of the time. They're really good at doing one thing at a time. They're not very good at multitasking. They're not very good. So all of even Scratch, where you're not actually writing code. Has anybody not heard of Scratch or not seen what Scratch is before? So I mean, Scratch is it's a good way to practice learning code. You do that. It's just dragging. It almost looks like Legos, where you have a Lego that says, if this happens, then do this, and you can plug in another one underneath it that says, then do this, and another one underneath it, and that says, then do this. So it's a good way to learn code without typing. But even that gets you in the mindset of thinking how a computer thinks. A computer, like I said, it does one thing at a time. Does this, and then does this, and then does this. And even that, even if it seems simple, even if it seems like it's not, I mean, it still is good. It still is a step in the right direction. But yeah, does that answer the question? Sort of, kind of.
No, I think that was perfect. So what would you say to kids who are interested in getting into this field, but maybe they're still in high school or even like middle school? Like, what can they do now to like learn more about this kind of thing?
Oh yeah. Like I said, Arduino, I think would be the easiest place to start. Arduino is all written in C++, so it's even the same language, and you can start with things. A lot of the groups that we've done at Cache Makers in the past, we've started with just blinking LEDs, and we've done 3D LED cubes that you can blink the different LEDs within the cube, or we've even done little displays with LEDs on them where you can write messages and print things out. We've made clocks, things like that. And that's all stuff, even honestly, that you can do at home. There's lots of really great kits and good tutorials online. Once things open up a little bit more, we can do more at Cache Makers, but that is easily something that you can start. And it's not even that expensive to get into. You can get a pretty good Arduino starter kit for $20 to $30. So it is something, but it's a decent start. Yeah.
Type it out so we can see, so you guys can practice this. And the cool part, while he's doing that real quick, is if you do a project as an LED project, there is a section in the fair. You can put in a poster about, look at this LED project that I made, or you could put in a notebook, or you could do a demonstration on how to code with LED, and you can earn ribbons and competition and stuff. So anyway, it's super cool, a really great opportunity to show off your skills while at the fair, and I'm grateful we're having the fair. So anyway.
Yeah, I wish I'd brought some of the projects that I've done in the past. I should have prepared better for this. Sorry about that.
No, you're fine.
But I mean, like she said, it's something you can share in the fair, something you can show off to your friends and things. I've entered and won competitions. There was a competition I entered once that I made a Christmas ornament shaped like a snowman. Had 3 little colored LEDs in it. Some of you might have made one at Cache Makers. I designed that, entered the design in a contest, and won the contest. Like you can do some really cool stuff and show off and share with people, and it's a fun way to get started in learning code and practicing code and electronics.
Sorry guys, I had to step for a second. Okay, that's really cool. So tell me what other skills you need to probably have if you're going to go into this kind of job, like maybe something that most people don't think about.
So as we've talked a lot about code, I mean, really quickly, a lot of my job also is electronics. I went to school for computer engineering, so I learned how to do code and electronics both. I don't design the circuit boards, but I do work with the guys that do. Outside of that, though, there is a lot of communication and things that you wouldn't think about. I actually write a lot of papers. I write a lot of papers and I write a lot of emails. And in my specific situation, it's kind of interesting because our company is owned by Samsung. Who's heard of Samsung before? Samsung is a Korean company, which means that a lot of the people that I work with, a lot of people that I interface with and that I have meetings and things with are Koreans, and English is their second language. So you have to be able to express yourself very clearly, and especially when you're talking about really complicated and really complex subjects to someone who doesn't speak English very well, you have to be able to make sure that you are expressing yourself in such a way that everyone understands exactly what you're trying to say, whether you're talking, whether you're typing an email, whether you're typing a paper. So, I mean, you wouldn't think that engineers have to write or have to talk or have to, but I probably spend more time writing papers and emails than I do writing code most days. So it is important to learn how to spell. It's important to learn good grammar. It's important to learn how to write and structure emails and how to write good, how to learn how to use Word, how to use Microsoft Excel. I use Microsoft Excel a lot. So yeah, all of that is important, even if you wouldn't think that it is.
No, those are perfect. Okay, does anybody else have any questions or thoughts they want to share? I think this is a super cool job. It's definitely not something that I could do.
You could, if you wanted to.
If I really wanted to go back to school for 4 years, 5 years, maybe. I'm kind of happy being done with school. Does anybody else have anything that they can think of they want to ask?
Are we going till 2:30 or till 3?
Maybe around 2:30 probably.
Okay, I have some other stuff I can talk about
Okay,
too, but
go ahead. I'll just
yeah.
let you go for it.
I didn't mean to pass that off and say I'm done. Ask questions. I just wanted to make sure we were there. So, who's ever designed a project before? It doesn't have to be related to code. Doesn't be related to electronics. Who's ever designed a project that you've worked on where you've sat down and had a plan, laid things out, and then worked through that plan? Who's ever tried to do a project without a plan? How did it go? How did it go? So obviously, when we're working on something this big, we had to start somewhere. So we break it down into smaller pieces. So let me grab real quick. All right, so we started out with this board right here. It's a lot smaller than the other boards that I've had, but it's got that same computer on there. So when we started working on it, when we decided we wanted to use this computer, we started with this little tiny board. And you can see how that's probably a lot easier than starting with the whole sign. We started with this little tiny board and we started just turning on a couple LEDs at a time, 2 or 3 LEDs at a time, making sure that it worked correctly, making sure that it did what we wanted it to do. And then little by little, we started adding more pieces to it. We have some of these boards that have wires soldered all over them, that have parts taken off. They have parts that we've burned up on accident and then had to replace. But we started small, which is kind of like what we were talking about before, that if you are interested in getting into something like this, there's absolutely nothing wrong with starting small, with blinking 1 LED or 2 LEDs or printing something out on the screen, because guess what? That's where we start too. So eventually we worked our way up to working with 1 LED card and this board right here. So, I mean, it's a little bit bigger. And this board right here can control about 8 cards, about 8 LED cards. It can't take HDMI, so it can only print out solid colors and maybe some moving lines and things like that. But having this allowed us to be able to test that our LED modules were working really, really well. And especially because we had different people working on the software for the LED cards that were working on this. And so it gave us a chance for the 2 people to work together and to make sure that all of our software was working correctly and doing what we wanted it to do before we moved up to the next step, which is this guy. This one is the one that actually controls the whole sign, or we use a bunch of these, I guess, to control a sign. This one, depending on how close the LEDs are to each other, so depending on how high the resolution is, this guy can control a couple hundred LED cards. But if we had tried to jump straight to this and we ran into a problem, it would have been a lot harder to figure out where the problem was coming from, because we're already dealing with a much, much larger scale. So just remember, when you're working on projects, it's totally okay to start small. It's totally okay I mean, the temptation, and I've been there too, the temptation is maybe to try and jump right to the big, exciting, flashy thing. But you're going to cause problems with that. There's nothing wrong with starting little, starting small, and once you have that working and once you're confident with that, then you can make the next step up. So if you're interested in doing something like this, definitely you can get started. You can work on things. You can try small things and build your confidence and build your skills and work your way up. So don't feel like you have to build a football stadium display all at once. It's taken us probably 3 years to get to this point. So
I love that. That's such a good analogy for your life too. Remember,
Mhm.
you don't have to be big.
Yeah, I mean, and it's easy sometimes when you want to try something new. I mean, if I one of the things that I wanted to do for a long time was make video games, and it's really easy to look at the awesome video games that you play and say, man, I want to make something like this. I'm going to make it exactly like this. It's going to be beautiful. I'm going to sell it for millions of dollars, and I'm going to retire, and it's going to be awesome. And you start to work on it, and pretty quick you realize, man, this is really hard. This is harder than I thought. And you get discouraged. You don't feel like you're making any progress. You give up. You put it aside. You never come back to it. Um, and you don't want to do that. You want to make sure that you start reasonably sized and work your way up, and don't compare yourself to people who have been working on things for 20 years. If you're just starting, it's your stuff is going to be smaller, and that's totally okay. Be proud of what you've done. Show it off. I mean, honestly, show it off to your parents, show it off to your friends. They're going to be impressed, even if it's not as big as the thing that you would like it to be eventually. Yeah.
No, that was perfect. Do we have any other questions? Mariana?
Kind of like you said, you need a plan mostly before you start. I was on a team for Thermo Fisher where we would be environmentally sustainability,
Mhm.
and we would do biodegradable plastics, which were also edible and help the environment. And we usually started off really small with really small kind of peanut sized
Mhm.
bioplastics, but then we started turning into paper sized and going bigger. And when you put them into water or you just left them be for a couple of weeks, they would just slowly start to degrade.
Yeah, that's really
Without
cool. I
causing
mean,
problems.
and if you started right away with the big sheet, you throw it in the water and it doesn't work, doesn't degrade like you want it to. You've wasted a lot more time. You've wasted a lot more materials. You get discouraged. It's better to start with the little stuff and to eliminate variables. I mean, if you saw only half of my sign is on today, that's because I am trying something new and I wasn't sure it was going to work. So rather than trying it on the whole sign all at once, trying it on half the sign. So if I mess up, I don't have as much to fix.
Yeah, we had to try a lot of recipes to
Yeah.
get the right one.
I mean, when there's 3,000 lines of code and you don't know which one you need to change. Yeah,
No, that
that's
was,
really cool. Thanks for sharing.
thank you. I think it's been really great. And the cool thing is like, there's so many things you can probably do with this kind of work, right? You know,
Oh
use
yeah.
billboards or whatever. What other things, like if they went into LED software, what other things do they?
Yeah. So the specific kind of software that I write is called embedded software. And what that means is that it runs on little computers on little boards like this, rather than running on like a desktop computer with a monitor and a keyboard and things like that. And there's embedded software everywhere. There's embedded software in your car. There's embedded software in your phone. There's embedded software in your big computer. I mean, all your mouse and your keyboard all have little tiny processors in them, and somebody had to write the code that goes on that. Every drones, remote control cars, if you've flown those before, basically every mission that has ever gone into space is all embedded programming. There's processors all over the rockets to monitor everything from fuel flow to trajectory to control systems to cameras to temperature sensors to the health sensors for the astronauts themselves. There's companies here in Logan even that make medical equipment that all has embedded programming. I mean, basically anything that is electronic that does something or has buttons or makes noise or something like that, but isn't actually like a laptop or a desktop computer, that has embedded programming in it. That's going to be the same code that I write, same kind of stuff. So, I mean, more and more and more, it's everywhere. You can do just about anything with embedded programming, and it all, you can start with the Arduino and start with C, start with Raspberry Pi, start with Scratch. It's all will work towards whatever you want to work on.
No, that was awesome. Okay, well, somebody who appears as Larson wants to know, which is better, Raspberry Pi or is it Arduino kits?
Yep.
Okay, what's his?
Good question. They're different. They're different. So for anybody that doesn't know, an Arduino is a little board. It looks about like this, but it's probably about half the size. And basically, It has all these little pins on it. You can see these little metal pins. You can connect wires to those and then connect that to LEDs or motors or whatever else. So you can make robots, or you can flash lights, or whatever you want to do with them. Arduino, you write your code for it in C. The nice thing about Arduino is that they're really cheap to get started. You can buy an Arduino itself for $5-10 if you buy them. If you buy it in a kit that has a bunch of stuff to connect to it, it goes up maybe $20, $30, $50, somewhere in there, depending on how many parts you have in it. But Arduino is a really good place to start. On the other hand, Raspberry Pi is a little bit different. It's again about this size, looks about like this, but it is an actual computer. So you can connect HDMI and USB, so you can plug in a mouse and a keyboard and a monitor and everything to it, and pull it up and play games on it or write code on it or whatever you want. But it also has these little pins on it, so you can connect it to different motors and LEDs and things like that. The biggest, so it's hard to say which is better. It depends on what you want to do. Arduino is going to be cheaper and probably easier to get started. And also, because it's cheaper, it's maybe less scary to get started, because even if you mess something up and the whole thing, lets all the smoke out and the whole thing stops working, you haven't lost as much. The Raspberry Pi can do a lot more, but again, it's more expensive. You now have to have a monitor and a keyboard, things like that. And for a lot of the starter projects that you're going to be doing, you probably don't need the whole Raspberry Pi. So if you're just getting started, you don't have any idea what you're doing, if you're wanting to know which one should I start with, I'd probably say the Arduino, just because it is a little more beginner friendly. But there's nothing wrong with jumping to a Raspberry Pi if that's something that you're interested in or something that you want to do. It has more power, but it costs more at the same time and is maybe a little harder to get started on.
That was awesome.
They're both really fun.
I just put links. I literally just found some on Amazon, some like starter kits. I'm sure you could recommend better ones, but those are the ones I found. Okay, you guys, if there are not any last questions. Oh, Larson says thank you.
Yeah.
We are going to go ahead and end this meeting. So we have, like I said, we have a professional photographer who's going to talk about what he does for a living next week, as well as Haley. She does other software designs, and then aerospace engineers. And then just stay tuned for more information about more Go and Sews, or we're going to have more of these string art kits available soon. And I know Cash Makers 4-H Club has some more STEM stuff they're working on. So stay tuned with your emails and social media. And thank Jonathan as you guys are leaving. I'm going to have you guys let yourselves out of the meeting, but just thank him on your way out. So bye, everybody.
Thanks, guys.
Bye, thank you.
Yep, bye. Thanks, guys.
Thank you.
Yeah, not a problem.
Thank you. Thank you.
Have a good day, guys. See if I can find all of those. I dropped a bunch of them on the floor.
Oh, you're fine. Hey, Courtney. What's up? I'm looking for Maddie. This is in their label somewhere. So, okay. Well, thank you so much.
Yeah.
I'm going to end the meeting, but that was really great. So
I hope that was
perfect.
I couldn't remember if you were trying to go for half an hour or an hour. So I
Well,
hope that's kind of what you were
I've
looking
gone
for.
anywhere. So honestly, it was perfect. So thank you so much.
Mhm.
I'll talk to you later.
Yeah,
Bye.
thanks.